The first problem is remove an element. It's pretty simple. The thing
Yeah.
that makes it a little trickier is you're doing it in place, but really not that difficult. So, given an integer array nums and an integer val, remove all occurrences of val in nums in place. The order of the elements may be changed, then return the number of elements in nums which are not equal to val. So, basically, is going to give us an array and it wants us
Hmm.
to return the nums array either with the elements that match the value being removed or pushed to the end of the list.
So you
Um,
want to return a number or an array?
it wants us to return a number, but the custom judge, you could see that it's going to take the numbers array, it has the value, and then it has the expected numbers. So it has the expected answer. Then it runs our function, whatever we end up coding up for our function, and we get k. So that's going to be the output 2 for this one, 5 for this one. But then you could see down here, it's gonna
Down where?
right here.
Okay, are you showing your screen on Discord? Okay.
Yeah, I'm
Oh,
sharing
I
it.
was I was checking the VS Code. Sorry.
Yeah, right on Discord.
Okay.
So you can see right here, this line of code, it's gonna take the numbers array that was passed in, and it's going to test it against the expected numbers array. So even though it's returning an output, it's still going to be using the numbers array that was passed into the function as a check later on. So actually modifying this numbers array in place is going to be important here.
Uh,
Yeah, so we can't just like count the numbers in the array and return that k without making any modifications to the numbers array. We actually have to make the modifications in place of the numbers array because we have this assert right here.
oh, so
Um,
we can't use something like filter or anything like that.
um, and then so you're saying you want to filter is going to take the nums array and it's going to create a new array, right?
Yeah, like you have this value. Like I could use a higher order method such as filter. I would It would be like something like nums dot filter, and then any value that is not sorry, any value that is not 3 would be filter out, and then you just output like the array dot length, which has uh, the amount of elements, right?
Yeah,
I'm not sure
so
if I get it.
because filter's not going to modify the nums array in place, it's actually going to give
Yeah.
you a new array. I'm pretty sure that method's not going to work because it's going to be
Mm-hmm.
testing right down here on this line. It's going to be testing the nums array. So
Okay.
let's just say for example, we take this example, we run filter on that and we filter out
Yeah.
all the 3, so anything that's returned is just anything that's not equal to 3. The nums
Yeah.
array isn't going to change. It's still going to be 3223. So when the test goes and runs the assertion on the nums array, it's still going to be the same exact array and it's going to return false. So we actually do have to
Mm.
modify it in place. But
Okay.
that's a good idea. That's a good idea. If it didn't have this right here, then yeah, we'd be able to just do that.
Yeah, because the thing is, I would have to remember exactly what kind of methods mutate the original array and which ones don't. So that's like something I would have to remember because
Yeah,
there are
that
other ways to do it.
yeah, that's fine. We could do some research if you want to look through that. I have a couple ideas on mind already. So one of them is actually let's finish reading through this problem first, just so we could
Okay.
see. So we have, for example, one, we have an array with 4 elements, 3, 2, 2, 3, and the value that we don't want inside of this array is 3. Output's going to be 2. The array that we're returning, or the modified nums array, should have the two twos in the beginning and then either the threes at the end or the threes removed. Your function should return k equals 2, with the first 2 elements of nums being 2. It doesn't matter what you leave beyond the return k, hence they are underscores. So anything past k, anything past 2 wouldn't matter. And same thing with this one here. We have an array with 8 elements. We want to remove the value 2, which is going to leave us 5 elements: 1, 2, 3, 4, 5, with the 2's removed, and anything past the 5th or the kth index isn't going to matter as far as the test right here goes. And
Okay.
then the constraints are the length of the array is going to be anywhere from 0 to 100. The value of each element is going to be anywhere from 0 to 50. And the value that we're removing is going to be anywhere from 0 to 100. So
Mm-hmm.
that's interesting too, since the value that we're removing is 0 to 100. If the value is ever greater than 50, we could just return the array that came in. Because if the value we're removing is 55, we know that there's never going to be an element inside of the array that's greater than. So that's
Okay.
like we don't really have to even think about that. We could build a solution without thinking about that, and then build it into optimize later. But just something to keep on mind.
Okay. So should I try something or should you try something? Like, how does it work?
Yeah, if you feel comfortable trying to solve the problem, you could feel free and go ahead and give it a go. Otherwise, I could go ahead and start implementing. I have a solution. I'm thinking of just splice, and then I'm also thinking of a solution with 2 pointers.
Hmm.
So I don't know
Okay.
if you were thinking about those solutions right there, but what are you thinking?
Um, yeah, I was thinking about splice, but like I was thinking about a for loop, uh, and basically if the value, if the elements like nums I equals value, then you splice it, right?
Yeah,
Something like that.
yeah, that sounds good.
Yeah, let me try. Like, do you prefer any terminology such as for of or for loop, or you know, does it matter much?
No, I do a little coding in C, so I always just do the for, just like the
So
traditional for loops. Yeah, let I
something
equals
like
zero.
this.
Yeah, yeah, yeah.
So this is an array. So it's dot length, right?
Yep.
I plus plus. Let me open this. So yeah, if um nums I equals val, then we want to do something. We want to we want nums splice. I don't remember exactly which like what they do. Like I remember, I think it's probably something like 1 0 or 0 1. I'm not sure.
So the first argument is gonna
Yeah,
be where you want to start splicing, like where you want to start cutting out. So let's just say
yeah.
where yeah, let's just say in this first example here, we're at the 0th index, I equals 0,
Hmm.
and num
Yeah,
0 equals val. Then the first argument in the splice will be 0 because you want to start cutting out from the
yeah,
0, and the second argument is how many you want to cut out.
yeah. That'll be always one.
Yep, there you go.
You just wanna. So, but the thing is, let's say so. Okay, so it's gonna splice it. So it's gonna remove that, and it's gonna be an array with 3 elements. So
Yes,
the next time, the problem is this is going to be one the next time,
yes.
and that's not good. So that should always be 0 because it's always going to be the first one.
Not always.
Uh, Not always.
No,
Mm,
because on the let's just say we cut out that 3, and then the next
yeah.
one we're gonna be
Okay.
looking at 2. Num
Yeah.
0 equals val. No, num 0
Oh.
doesn't equal. So I is now gonna be 1. So
Okay.
you were right the first time.
Okay. So let's say
Yep.
it starts at 0, then it cuts the 3, right? So the next one's gonna be 1. So it's gonna keep this one and cut this one if it's the val, which is not. Then it's gonna, yeah, there's a problem here. Like I
Yeah.
feel like it should increment uh in a way where it considers if something was spliced, something
Yes.
like,
Yes.
yeah, something like select.
Let's go ahead
Okay,
and
all right,
just
I
put
got.
this. Yeah, you're right, because we do have to write a little bit. We have to write a little bit extra code with the way that the for loop is set up right now, but there might be a way to modify it now. So since this for loop is going to increment I with each iteration, so after we run this code here, I is going to increment, then you could just do I minus
Account, right?
minus. You could just do
Oh,
I
that's that.
minus 1.
Okay. Yeah, what I was going to do is like I was going to keep a count outside of the for loop that was going to increase, and then it would be like I minus count. But that makes a lot more sense.
Yeah, if we're gonna cut something out, then and we know that I is gonna be incremented, then. But if we're not gonna cut it out, then we don't want to decrement. We just want to increment and
Yeah,
go check
I
the next
I
one.
think that seems to be a nice solution. I mean, we should test, of course, but
Yeah,
that
let's
seems
go ahead.
fine.
So let me see. I'm gonna run node 1.js. We have undefined and undefined. So the
Yeah, because
function
we're
is
not
not
returning
returning.
anything.
Yep.
We have to return nums in line in between line 12 and 13, right? After the for. I can do
Yes,
that, like
sir. Do your
return
thing.
nums. I think so, right?
We're actually not gonna be returning the array. We're gonna be returning k. So
Return.
how many elements are left in nums?
So length, okay.
Yes, nums.length. Perfect. All right, cool. Let's test
Okay.
this out.
Yeah,
We're
I gonna test it
getting
on lead
we're
code.
getting 4 and 8. So
Okay,
so
4 and 8.
there's a problem here.
Mm-hmm. Okay. Let's
What
see.
is I initialized as?
Oh, yeah, initializes nothing.
There you go.
Uh,
That should work right there. Let's see.
okay.
Yep.
Okay.
2 and 5. Perfect. It's working.
Can I see it again, please?
Yes, sir.
I was on the VS Code thing.
Yeah. I'm just running node
Okay,
1.js.
yeah, 2 and 5.
2 and 5. So if you look at the
Okay.
solutions, we're expecting 2 and 5. Yep.
So are you going to try to pass it on LeetCode to see if there's any edge cases or anything like that, or
Yeah, we can go
do
ahead and
you
do that.
usually
Let's.
just take it as a truth?
No, I posted it into LeetCode. You have to put it in
Okay.
there. Yep. So we're good to
Okay.
go.
Why is
Runtime is better
memory?
than 62%. Memory is a little crappy. Let's see what we got here. So
It
this
seems
actually.
fast.
So there's one thing we could do where we could eliminate this line of code, I believe. So you know how we have to decrement I every single time we splice it out
Yeah.
because it's in the beginning? If we start from the last element and we work our way to the
Mm-hmm.
front, I believe
Okay.
that we won't have to splice. So if we just initialize,
Oh, I see.
let's
Yeah,
do
because correct me if I'm wrong, but when you splice from the beginning, it has to recreate the whole array, right? And it's like it's more expensive than if you remove from the end of the array. Is that correct?
yeah. So this makes it an O of n squared solution because we have this for loop
Yeah.
right here, which
Mm-hmm.
is O of n because
Mm-hmm.
we're going through each element in the array. And then splice, worst case scenario, like we remove this 3, then we're shifting every single element over
Yeah.
1, so n. So worst case scenario, this is O of n, and this makes the overall, this for loop with the splice, an O of n squared.
So should we do reverse and then do something like I think it's pop, right?
Um, so
Or in shift or
this is
shift
one
something
thing
like
we
that.
could do. I'm gonna go ahead and just say let n equals nums dot length. I'm gonna
Mm-hmm.
put n right here, and I'm gonna initialize I as n minus 1. So if the length is 4, I want to start at the 3 index, and then
Yeah,
we'll
makes sense.
decrement I, and then if we splice, let's just say we splice the third element here, and then we decrement I, then we'll be moving to the 2 element. So we're
Oh
never
yeah. Okay, I'm sorry. You have to use splice. You can't use pop because otherwise it's going to always remove the last one. Yeah, makes
yeah,
sense.
yeah, exactly. So let's
Yeah, but
test this and see. Oh,
you have to change the
while
splice, right?
I is greater than or equal to 0. There we go. That should work. 2 and 5. Yep. All right. Let's see how this one
Okay,
compares.
okay. So why don't you have to change line 11? I
Well,
thought line 11 would have to be changed,
no,
right?
we're still splicing. So whether we're starting from
Oh yeah.
the 0 element, splicing that, and then
Hmm.
moving to the next one, splicing that, moving to the
Oh
next one,
yeah.
we're still splicing from the end. So with this,
Hmm.
with I equals n minus 1, for this example, n equals 4 in the beginning, right? Because the length is 4. So n minus 1 is 3. We're starting at this 3 element right here. Then we're going to run this loop while I
Yeah,
is
yeah.
greater than or equal to 0. So we're going to start at the 3 element, move to 2, move to 1, move to 0, and that'll be the last one. And so
Yeah,
if
yeah.
we're starting at the third element here and num's I here does match the value we want to remove, we'll splice starting at 3. So right before
Hmm.
this 3, we'll cut 1 out. So we'll cut that out.
Hmm.
I is still equal to 3, but
Yes.
now since we decrement 1, then we're gonna move I right here to 2. So now we're at 2.
Yeah, yeah, yeah. I got it. Like for some reason I thought you had to change there, but yeah, it makes sense too. But is it still ON now that you're removing from the end?
This is just an optimization on the splice method, but we're gonna try another method after this. Let's just see how this compares. 6221.
Yeah, it's worse. Just
So
kidding.
this is better runtime wise in the
Yeah,
94%, memory
that's good.
wise 80%. There's still a better way to do it though.
Yeah, because it's
Runtime wise,
ON squared, which you don't want, right?
it's
So there
still
must be
O
a
of
smarter
n
way.
squared. Exactly, exactly. So let's see. We already have this here. Let's leave this here just for reference.
Sure.
Um, and then there should be a pointer solution. So let me use this array as an example.
Mm-hmm.
So let's say we have J and I,
Mm-hmm.
and if num's I does not equal val, then we'll increment I. So what is val is 2 in this one. So let's just say let val equals 2. And this is just for the example. So
Mm-hmm.
I does not equal num's I does not equal val, so we'll increment. Or it doesn't equal val, so we will set num's j is I, which it already is, but that's okay. Then we'll increment j, increment I. Since
Just this is like pseudocode, of course, but is I and J like two for loops inside of each other?
I will be the external for loop and j will be a variable initialized before we even start the for loop.
Okay.
So let's just
Yeah.
say then on the next iteration, num's I is not equal to the value. So we set num's j equals num's I, increment j, increment I. Now num's I is equal to the value
Mm-hmm.
that we want to remove. So we'll increment I. We'll just continue. Now it's equal to the value we want to remove again. So we'll increment I again. We'll just continue and increment I because the for loop is going
But
to increment. So we'll
J
just
stays the same.
j stays the same. Now we land on an element that is not equal to the value we want to remove. So num's I is not equal to val. Then we store the value of num's I in j. We have 3. Then we increment j, increment I. Same thing here. Nums I is not equal to the value we want to remove. So we'll set nums j is equal to nums I, increment j, increment I. Same thing, it's not equal, so we'll set it. Increment. Now it is equal to 2, so we don't want to do that. We'll increment I. That'll end the for loop. And then
Yeah.
we should get back 0, 1, 2, 3, 4, 5. So we could just return j from the function,
Mm-hmm.
and the array was modified in place. So if you look at 0, 1, 3, 0, 4, that's exactly how we want to modify. Yeah, so we could go ahead. I'll go ahead and write the pseudocode, and
Okay,
then you want to
just
type it out?
just one thing, like so you still have two at the end of the array. That's fine.
Yeah, that doesn't matter because anything after k. So if the output's going to be 5 or it's going to be j in our algorithm, 0, 1, 2, 3, 4, 5, anything after that's not going to matter.
Okay.
Yeah.
Uh, yeah, I'm not sure if I can write that, but I can try for sure.
Yeah,
But
you can.
I'm not. So okay, I can try if you want me to.
You want me to write the pseudocode or you want to just wing it?
I'll let you write the pseudocode and then I'll try to implement it, I guess,
Okay. We'll initialize
if
our.
that's okay.
Yeah, sure. Iterate over nums array. So the first one is we're just initializing our base pointer, our j to 0. We're going to iterate over the nums array while inside the for loop. If the current, if the, we'll say leading pointer, because the one that's kind of like taking the lead and going ahead, if the leading pointer is not equal to our base pointer's value, if our leading pointer's value is not equal to our base pointer's value, then we will store the value of our leading pointer in our base pointer. Then we will increment our base pointer, and actually we could do is equal. If it is, this will probably be simpler. Then just continue. Otherwise, we won't continue. We'll run this code here. So store the value of increment our base pointer, and cool. Then we'll just return the base pointer, and that'll be j. All right, so initialize our base pointer, iterate over the nums array. If the leading pointer's value is equal to the base pointer's, actually, if the leading pointer's value is equal to our value,
Mm-hmm.
continue. Otherwise, run the code down here. And the code down here is going to store the value of our leading pointer in our base pointer, um, modifying the array in place. And then we will increment our base pointer. The for loop will automatically iterate our leading pointer, and yeah, then we'll just return the base pointer. That should be good.
Okay, so the base pointer would be J and the leading pointer would be I, right?
Yes.
Okay, let me give it a try. I'm probably not gonna get it right, but I'll try anyway.
Nah, it's all good. You got
Uh,
this.
since this is gonna be modified, I guess I should use let j equals 0.
Yep.
So you're gonna iterate over the nums array. Should we do it from beginning to end like we you did in the example?
Yeah, I would.
Okay. So for let I equals 0, I assume the same constraints apply here, num's length,
Mm-hmm.
and then we increment.
Yep.
So we're gonna iterate over the nums array. So okay, no, thank you.
Got you.
So so if um deleting if I equals j, uh we continue like we can actually use this continue.
Yep.
Okay.
That'll just skip
Uh
everything else in the for loop and just start over.
okay, awesome. Because I've heard of continue and break, but I never really use it. Okay, so continue. Otherwise, okay, store the value of leading pointer. Okay, so uh, there are usually ways doing it with temp, but I usually do this. I don't know if you like it or not, like something like this, where you switch values. I don't know if it, but you don't want to switch values, do you?
Why do you want to switch?
Yeah, because I want to copy the like say store the value of the leading pointer, which is I,
Mm-hmm.
to our leading uh in our base pointer, but you don't want to switch them around, so that's probably not it. So it's something like
Yeah, so let's say
uh
J is pointing to this zero element, and or let's just say J is the second example, J is pointing to the zero element
mhm,
and I is pointing to the fifth element or the four indexed
mhm.
element. And we want to take this value, the 3, and overwrite this value. How would we do that? Since
Oh
this
God.
one's, you're pointing to this one with J, you're pointing to this one with I, but you still need the nums identifier to target these values with I and J. So if you want to store this value at I and the value that's at the location J, how do you do that?
Oh, I'm not sure if I get it. Let me think here. So because they grow together until we find two, right? Then I increases, but J doesn't. Isn't that correct?
Yeah, so J is basically going to sit there and wait
Yeah.
until I finds a value that is not the value we're trying to remove.
Okay. Um, so if I equals J, we continue. Otherwise,
Let me ask you something really quickly.
okay.
Are you comparing the value of I and J, which in the first iteration would be 0 and 0,
Uh,
or are you trying
no,
or are you trying to
I mean,
compare the value of the element?
yeah, I guess I'm trying to compare the value of the element, right?
Yeah,
Okay, I'm gonna assume this something like this.
perfect. Perfect.
So let's say nums 0 would be 0, which is equal to J. So it skips. Then I would be 1,
And
which is
are you
not equal to J.
let me ask you this. Are you trying to compare so I is going to be moving through this array one by one, right?
Yeah.
Are you trying to compare I to the J that's like behind it? Or are you trying to compare I to something else to see whether you should replace J?
Oh God. Okay, maybe you should do
No,
it.
it's all good. It's all good.
I don't know.
Because
It's hard to think.
we're only replacing nums J under certain circumstances, right?
I didn't even know there were such a thing as nums J. I just thought J would be something um like we found a number, we would increase it, like but yeah, the two pointer techniques is not something I got down, but we can try. Let's see. uh if the leading pointer's value is equal to our value, continue. Okay, that's doing it. This should not be here,
So
it should be here.
let me just say something really quickly. On this second
Mm,
example here, the second array, there's going to be a point where J is pointing to this element So so nums j is 2, right?
Yeah,
And then there's going to come a point where I is pointing to this 3. So nums I equals 3.
yeah,
Now we want to replace this 2 with nums I, right?
yeah.
Because nums I is equal to the value, or because nums I is not equal to the value when we're trying to replace the value?
Yeah, man, that's a little bit beyond my scope.
Yeah, so basically,
Sorry, I'm trying
no,
my best here.
no, it's all good, man. You're doing good. All right, so if nums I equals this value that we're trying to remove from the array, then we want to continue. So instead of j,
Okay,
we'll
so
just go
val,
with
yeah,
nums I
okay,
equals val. If nums I equals val, then we continue. Then we just,
okay,
because if j is if j is on this 2 and I is on this 2 and nums
mm,
I equals 2, we just want to skip. We just want to now we want to move I here. And now I is nums I is still on a 2. We want to move I again. So we want to continue moving I until we reach a value that's not 2. So if nums I, which would be 2 in this case, equals value, just continue. Just increment it. Move to this one. Nums I still equals the value that we want to remove, just continue. Nums I doesn't equal, so it doesn't equal. Now we just skip this continue. Now we're not continuing. We're going to run this logic
hmm.
down here. In this case, we want to replace nums j with nums I. And that's just a simple assignment.
So it would be something like nums j nums I equals nums I, because I don't want to use temp.
Now I know what you're thinking of too. I've seen this logic before in like React or something, so I know what you're thinking of. But
Yeah,
it's
it's just
it's
like
actually way
changing.
simpler than that.
Okay.
Because
Okay.
you have this value here. This is nums I, right? And
Nums I, yeah.
you have this value here that's nums j. You just want to store this value inside nums j. So it's literally gonna be
It's like splicing.
so target num j and take
Uh,
point to
we're gonna
num.
use
I'm trying to
splice
explain
here.
it. Point to num j
Sorry.
and pass num I value to num j. So this is kind of like the logic here. It's even simpler than this. I'll go ahead and type it out, and you're gonna be like, "Oh my goodness, watch."
Yeah,
So
probably.
num j equals nums I. That's it. You're just taking the value that's sitting at nums I, that 3, and you're storing it in nums j. That's it.
Yeah, the syntax is easy, but I still don't understand what's going on in the code in line 17.
All right, I'm gonna show you. So
It's not as simple as it looks for beginners.
I know. All right, so I'm gonna just start from the beginning here. So we're starting with j and I both on 0,
Yes,
right?
right,
So we have nums j equals 0. We have nums I equals 0
correct.
at this current moment, right?
Okay,
And also we have I equals 0 and j equals 0. And I'm using this just to show you as we move them along, right?
yeah,
So
correct.
that's jumping into this for loop here. Now we test. If nums I equals val, continue. Does nums I equal val?
No.
What is num?
Nums I is 0 and val still 2. Sorry, which one are you doing? Like the first one or the second one?
We're doing just this first one here. So I equals
Okay, sorry.
0, j
Okay.
equals 0, nums I equals 0, nums j equals 0. Both I and j are pointing to this first element to begin with, right?
Yeah, nums I is not equal to val,
All right, so in this case, we want to take the value of nums I and store it
which is
in,
0.
yep, and store it in
Okay.
nums j, which is already 0.
Okay.
So
So
it's sort of repetitive.
So okay, so J doesn't move, but I does.
Now in this case, J does move. So
But it's zero.
that's the next logic here. J doesn't change. The value of nums J doesn't change. It stays the same.
Okay.
Yeah, because you're literally just taking this right here and storing it in this. And so there's no change, but you're doing it anyways. Just because writing edge cases for it would be way more complicated than just doing this. So in this
Okay.
case, nums I does not equal the value we're trying to remove. Store the value of nums I in nums J and increment J. So we'll move J to the next one. Since we're at the end of the for loop, we'll also increment I. Now we do the
Yeah.
same thing. If nums I equals val, continue. Nums I doesn't equal val. So we take the val, but now I equals 1, and J equals 1, nums I equals 1, nums J equals 1, right? So
Yeah.
we take since nums I is not equal to val, then we skip over this continue. We don't execute it. We actually run this code inside the for loop. We take the value of nums I, which is 1, and we replace nums J with it, which we're not making any changes, but it's just a technicality. Then we
Yeah.
increment J by 1. So boom.
It's only going to do something when you find the value, right? So
Well, I is going to change when we find the value. But the first time we
okay.
encounter the value, this is where it starts getting interesting.
Yeah. Yeah,
So
that's what
we
I meant.
increment J, and then the for loop is going to increment I automatically. Now, nums I does equal val. So we're not running this
Okay.
code anymore. We're just continuing. We're not going to
Mm-hmm.
increment J. We're just going to increment I.
Mm-hmm.
So J stays here and just waits. Now, I's responsibility is just finding the next value that does not equal val. So
Okay.
now I equals 3, J equals 2, nums I equals 2, nums J equals 2. And then we test this again. Nums I equals val? Yes, it does. It equals 2. So we
Yes.
just continue. We increment I again. Now I equals 4. It's on the fourth index. Nums I equals 3. Nums J
Just
still equals 2.
what? Why did it increment twice?
That's two different iterations because on
Oh, okay.
when it was back here, oops, nums I was equal to value. So we just continue. And if we continue, we skip all the rest of the logic in the for loop and we increment I and then we just start the for loop again. Now if nums I equals value, which it does, it equals 2, then we skip all the rest of the logic in the for loop and we just continue. So we increment I. Now I equals 4. So we're targeting nums 4, which is the value 3. So now,
Yeah.
does nums I equals val? No, it doesn't. So
No.
we don't run this continue. We actually take the value that's in nums I, which is 3, and we store it in nums J. So since J is still
Okay. Okay.
pointing here, we take that 3 and we overwrite that 2. Then we increment
Okay.
J. So now J is 3. We're at the end of the for loop. We're going to increment I. I equals 5. So nums I is now equal to 0. And then we do the same thing. If nums I equals val, then we just continue, but it doesn't. So we take the value that's in nums I, we store it in the value that's at nums J, which is 0. Then we increment J. Boom. The for loop, since we're at the end of it, is automatically going to increment I. And then since this 3 that J is on right now, we already move forward. So
Okay.
we're able to overwrite this now, you know. So we're going to be able to overwrite this 3 if I is on a value that's not equal to the value we're trying to remove. And so now I is on the 6th, J is on the 5th, I is equal to 4, nums J is equal to 3. and nums I
Oh,
is equal
wait,
to val.
isn't J in the fourth? J equals 4, right? That's the
Nums j is 0, 1, 2,
no no
3,
no
4. Yeah, yeah,
J
yeah. Yep. Yeah,
4.
you
Okay.
got it. It's on the fourth. Its value is 3. So now, same thing. If nums I equals val, which it doesn't, it equals 4. We continue, but it doesn't, so we actually run the logic within the for loop, take the value that's nums I, and replace nums j with it, which is 4. Then we increment j.
Yes.
Boom. For loop increments I.
Yeah.
If nums I equals value, which it does, the value is 2, we just increment I, skip to the beginning of the for loop, and this for loop is only executing while I is within bounds. But since now I moved
Yes.
outside of bounds, this function is over. Um,
Yes.
j equals 5, so that's our k value. Our k value is 5, and the only relevant elements inside this array that we just modified are the first 5. So when the test is done
Okay.
on this function, it's going to test the first 5. The 3 that come after it just are going to be irrelevant. It's like they didn't exist. We could have removed them like we did with the splice, but we didn't. We just shifted the important ones to the front, and j is what we're going to be returning.
Okay. I just don't understand how it helps you know how many twos, how many number twos, which is the value, right, were
Yeah.
removed.
You don't have to know how many were removed. You just have to know
Isn't
how many elements inside of the array were were not that value. And since we have the value of j, we know that 5 were not twos because we started with 3 twos, right? Element 2, 3, and 7.
Yeah, I mean, the output should be a number. It should be three, right? Because there are three elements too. Is that correct?
No, the output should be 5. So we
Oh,
want to,
because you're removing, yeah, because you're removing the elements. Makes sense.
yeah.
Oh,
The
I think
output
I
should be
understand that.
5 because there's 5 elements in the array that are not equal to the value.
Mm,
There's 5 left.
okay,
There's 5 left after removing the value you want to remove.
yeah. So let's see if I get it right. Line 36. J is at the index 0, 1, 2, 3, 4, 5. It's index 5, right?
Yeah.
So index 5, index 6, and index 7. That's 3. That's the amount of values of 2 that are inside the array. So that would be kind of like, we put everything that is not 2 here on the and whatever's on including here from the right doesn't really matter
Mm-hmm.
in our count.
Yep.
So that's the logic.
Exactly. Yep.
That's pretty tricky, but it's cool though.
Let's see if it works.
Yeah, that's the more sport part.
That is.
Imagine like this one.
So what are we returning here?
We're returning. I assume J.
Yep.
Um, right?
Yep.
Yeah, because it's outdated there. It should be like 5, right, on line 29.
Mm-hmm.
Okay, yeah, I think we return J then.
Cool. Let's see. This is 2JS. So we'll run 2 and 5. Let's test it in LeetCode though.
Okay, I'm gonna go into your screen. Okay, let's hope. Let's pray.
Let's see how it compares to the splice.
It's probably better, right?
No way.
Oh,
Look at that.
what? What the?
Well, with memory, that makes sense because we're creating an extra variable, but it should definitely beat the runtime. So,
Yeah, it probably could be like your browser and the fact you're streaming or something like that.
there we go. Yeah, they
Yeah.
they run on different servers. All right, so we got 73, 73, which is it's still way better than the first solution. It's
Oh
just,
yeah.
yeah, I wonder why.
Uh, so yeah, it says 49. The first solution was like 51, then 43, which is an outlier, it seems. And then 63, which is probably more like it.
True.
And and then 49. Okay.
At the end,
Okay,
at the end of the day, though, with the solution like the first one with splice, it might be just the constraints. Like the constraints are so small that maybe it's more
yeah.
efficient to use something like splice with the problem this small. And
Yeah.
but if the length of the array was like 7 billion or 70 billion, then this would definitely blow the other one out of the water, you know.
Yeah, which by the way is often the case with lead code.
Yeah.
So that seems to be an exception.
So this is O of n right here. We have this is O of
One
1
over, okay.
space. This is O of n time. O of 1, O of 1, O of 1, O of 1. So overall, this solution is O of n. So it's way better than the other solution for sure.
Okay.
Yeah, we got about 5 minutes, so I'm not gonna have time to go into the
It's
other.
fine. I have soccer, so
Okay, cool, cool. You have any
okay.
questions before we take off?
Yeah, let me see the second code again. Maybe I okay. So how would you summarize the two pointer technique? Like it's called the two pointer technique, right?
Yeah.
Because I've heard of the two pointer technique, but I think it's probably something else, which like I starts at 0 and the J starts at the end of the array. I think it's like sliding window.
Yeah.
So
Well,
they're
there's
different things,
there's
right?
there's a bunch of different things you could do with the 2 pointers. Like for us, we started both of the pointers on the 0 element,
Yeah.
and we had one leading pointer that was kind of like its responsibility is going ahead and finding an element that's not equal to the value. When it finds the value, then it basically sends that value back to the our base pointer. But if you were looking at this solution, I'm not going to go into it. This is just another the pseudocode I have here. It's another pointer problem, but with this one, I actually sorted the array. So I would do
Mm-hmm.
like I had -4, -1, -1, 0, 1, 2. So I sorted the array first,
Yeah.
and then I had I. So I had my base pointer the same way we did in this one,
Mm-hmm.
but then I have a left pointer and I had a right pointer. And I start the left pointer on this value and I start the right pointer on the last element. And
So using
if
sliding window.
yeah, so it's you're using pointers still, same with the previous one, but instead now we're moving the left one to the right and the right one to the left depending on what the value is until this left one lands on right or passes right. So if it ever comes to the point where left is equal to right, then we increment I and we start all over again.
Okay.
So there's like so many different ways you could use the pointer technique, but essentially you're just using in our case, we're just using a pointer. They both start on the 0 index, and one is the leading pointer that's sort of like the explorer searching for an element that's not equal to the value we're trying to remove. Once it finds that value that
Yeah.
we're not trying to remove, it takes that value and it sends it back to our core and just
Yeah.
overwrites it basically.
The way I like to think is that I is a very fast guy. He's not hungry. He doesn't want to stop at the restaurant to grab something to eat. But Jay does. And whenever Jay finds the kind of food that he likes, he stops. So that kind of helps me, visualize it better.
Yeah, I
I
like that.
don't know if it makes any sense.
Nah, I like that analogy. That's a good one.
It eats the elements, and then the elements is gone away from the array. Uh, and now it belongs to Jay. I don't know. I don't know if it makes any sense. Like one more um, one more meal. We had a meal at the end of each run.
Yeah, I
Each
like that.
successful run, of course.
Yeah, that analogy makes it make more sense for sure.
Yeah.
Yeah, I need to think of an analogy that makes sense. It's just so different depending on the problem. You know, the way you use the pointers is different. But yeah, you summed it up pretty nicely, man.
Oh, thank you. Yeah, I try to do that because it's easier for me than to think in such an abstraction. Uh, like I try to create a mental picture of it because it does require some memorization, right? It's
Oh
not something that you're gonna come up with unless you're really, really gifted.
yeah, yeah. There's definitely some memorization as far as like different techniques and
Hmm.
that sort of thing.
Yeah,
And if you can use a story or an analogy, it definitely makes it easier to remember and store this stuff for
yeah.
sure. Yeah. It's hard to remember numbers.
Yeah, I'm gonna think about Ian and John. Ian doesn't want to eat; he just want to go. And John's like, "Hey, man, I want to stop to eat. Well, can I find the meal that I like, which is two, or something like that? I don't know." And then he eats it.
Yeah, Ian is exploring the potential restaurants that John wants to eat at. John is just like an overweight dude who's kind of taking his time
Yeah,
and waiting, and Ian is ahead of him, just texting him like,
yeah,
"Hey, I'm at this restaurant. This restaurant has this type of food, and this type of food is all the values except two. But John doesn't eat twos. John only eats numbers besides two, so it has to be a value besides two. If it's a value besides two, then John will accept that. He'll hang out and yeah. So
yeah.
I
Like
see where you're going with this.
yeah, yeah, yeah. Like maybe he was like allergic or he has to eat at a place that's like gluten free and vegetarian and vegan and all
Yeah,
that.
yeah.
So he's really picky. So
I like that. I like that.
okay.
You got any thoughts on this, Fernando? Before we take off?
Um, yes, the last about the last solution, I was thinking because when you use the slice method, it seems very fast uh, than the just setting the values from the two pointer uh, approach. Because I tried this solution, I made some similar solution, but it just reached to the 80% or 70%, but with the slice method, I think it's probably something that JavaScript's doing under the hood.
Yeah, true. And at the end of the day, it's only splicing out when you encounter a value that matches the value you're trying to remove. So, like the number of elements that are actually shifting, if the maximum number of elements in the array is 100, could be less than the number of operations it takes to. No, no, could yeah, yeah. You're right. JavaScript probably has some optimizations under the hood that they have for those types of problems. That would make more sense. Because now that I'm thinking about it, the number of operations overall is definitely more for the splice, but there has to be some type of optimization under the hood.
Hmm.
That's what's up though. And honestly, when there's only 100 elements inside of the array, wasting my time on a pointer
Yeah.
solution, I feel like is just a waste of time, especially when you're competing and you're doing the data structure and algorithm competitions. I just want to build a quick splice method, get it out of the way, and move to question two. You know?
Yeah, but Jim, for a job interview, I think the second solution would be more impressive to employers than the splice one, right?
I think for a job interview, it would be more impressive if you started with the simplest brute force, like the splice solution, but then you're like,
Yeah.
what? And then you explain your thought process, like, well, this is O of n squared because the splice inside of the for loop makes it O of n
Yeah.
squared. I think there might be something better. And you start thinking through it, and then you're like, huh, I might be able to use two pointers. And you show that you not only can create a brute force solution just to get the problem working, but you can optimize it in
Yeah.
front of them. They want to see that,
Hmm.
you know?
Awesome. Awesome. That's the kind of insight I'm looking forward to.